Binoculars, Design and History, a presentation by Jerry L. Bell on behalf of the Village Birders. Lenses. Merriam-Webster defines a lens as a piece of transparent material, such as glass, that has two opposite regular surfaces, either both curved or one curved in the other plane, and that is used either singly or combined in an optical instrument for forming an image by focusing rays of light. Some naturally occurring lenses made of gems or lightning-fused sand, such as the 3,000-year-old Nimrod lens found in 1850 in Iraq, have been used to magnify images. Franciscan monk Roger Bacon suggested using sheets of convex glass as reading aids in 1267. Lenses. People eventually learned to create relatively clear glass and crystal to shape them into forms that worked as magnifying lenses. Ancient Romans made glass lenses that could magnify by as much as 2½ times. Anthony van Leeuwenhoek developed a single-lens microscope in the late 1600s. Lenses. In the late 1200s, craftsmen put convex lenses in frames to deal with farsightedness. In the late 1400s, Nicholas of Cusa used concave lenses to deal with nearsightedness. Combining lenses. In early 1608, Hans Lippershey of the Netherlands combined convex and concave lenses in a 12-inch tube to create the first 3-power telescope. Within a year, Galileo Galilei made his own spyglass with better lenses and a longer tube to create a 20-power telescope. The images from these simple telescopes are inverted, both left for right and top for bottom. Shortly thereafter, militaries combined pairs of telescopes into the first binoculars. Porro prism. This is what most people think of when they hear the word prism, an isosceles triangle made of glass or crystal. Light enters the base, bounces off the two sides, and exits out the base. The image is inverted, both left for right and top for bottom. Porro prism binoculars. In 1850, Ignazio Porro invented the idea of passing light through two sets of triangular, Porro, prisms to uninvert the image through convex-concave lenses pairs in telescopes and binoculars. In this design, the path of light through the barrel seems to make two opposing 90-degree turns. Reverse Porro prism binoculars. Somebody eventually came up with the idea of flipping the Porro prism design on its head, resulting in the reverse Porro prism design. This design allows for very lightweight, compact binoculars, often called opera glasses. Roof prisms. There are many other kinds of prisms and combinations of them, including several collectively referred to as roof prism designs. The Schmidt-Pichon, the Abbe-Koenig, half pentaprism, Maddox prism, Lippmann prism, Amici prism, Dove prism, Abbe prism, Kutter prism, Roshan prism. Roof prism binocular. In 1870, Achille Victor Emile Dalbrès used different types of prisms in the first roof prism binoculars. In the roof prism design, the path of light follows a straight line through the barrel. In 1897, Maurits Hensoldt started marketing roof prism binoculars, bringing them to the mainstream. Schmidt-Pichon prism. A type of Amici prism made by gluing two right-angled prisms together with a thin sheet of flint glass between them. The lightest and smallest type of roof prism configuration, used in the majority of roof prism binoculars. Abbe-Koenig design. A more complex prism design that is heavier and more expensive to make than the Schmidt-Pichon. better light transmission resulting in brighter image, introduces less distortion than the Schmidt-Pichon, a less compact design requiring models that use it to be longer than Schmidt-Pichon based models, used mostly in higher-end models by premium brands like Vortex Optics, Swarovski, and Blazer. Lenses, prisms, and more lenses. Modern binoculars are more than just a convex lens, a concave lens, and a couple of prisms. To reduce various kinds of distortion and increase clarity and power, multiple lenses are used. Each lens and prism can be made from a variety of glass, some of which distort less and pass more light, but can be heavier and much more expensive. Each lens and prism surface needs not only to be polished, but should be coated, or better yet, multi-coated for optimal performance. Modern binoculars. The three main types of binoculars on the market today are Poro, Reverse Poro, Roof. Poro and Reverse Poro prism versus Roof prism. Poro prisms. This design was pretty much the standard until the 1960s. Pros: better depth perception, wider field of view, better clarity, better image quality, less expensive. Cons: bulkier, less powerful, heavier, less durable, harder to grip, more difficult to manufacture, and much more difficult to waterproof. Roof prisms. This design has been pretty much the standard since the 1960s. Pros: compact, lightweight, easier to grip, more durable, more powerful, much easier to make waterproof. Cons: less depth perception, narrower field of view, more expensive. Digital binoculars. Another category of binoculars is a combination of conventional lenses and digital electronics. The advantage of this design is that it allows for the inclusion of features like image stabilization, digital and still photography, video recording, and even enhanced night vision. The disadvantage of this design is it adds the weight, bulk, cost, and complexity of digital cameras, image stabilizers, and night vision equipment to the existing weight, bulk, cost, and complexity inherent to binocular design. End of presentation. Thank you for viewing Binoculars, Design and History. This has been a Big Dummy presentation.